So I hope that today, after my presentation, you might have some ideas about how we can get the structural engineering approved by the council. What I'm talking here is the council in South Australia, maybe in Victoria or other states. The council's policies are a bit different. So you might check with the local council to see what they really required. But by myself, I'm Thomas Ha. I'm a director of MLEI Consulting Engineers in Adelaide. We register nationally, so we can provide design, in any state in Australia. We are enthusiastic and passionate about sustainability design, so that's why we participated in some of the sustainability groups in South Australia, where I met Martin. And he introduced me to the concept of Earthship, and he also invited me to attend one of the seminar by Mike Reynolds in Adelaide, and that's very interesting. In 2012, we won the Zero Carbon Challenge with the team Collaborative Future, where we designed a house with zero carbon emission, or air emissions, sorry. So I'm very lucky to assist Martin with the structural design of his Earthship in Ironbank. I just want to talk a bit about this project. You probably have listened to it before. So it's in Ironbank, South Australia. The site is quite sloping, which is good. So Martin doesn't have to build a big earth berm. So it's bed and breakfast, so one bedroom. So we have tile walls and with a ferro cement vault for the main bedroom and also at the front. And for the front area, we use a timber frame roof. So the engineering design features of this Earthship is like we don't use concrete footing, because Martin's specified or said that he doesn't like cement and concrete because it consumes a lot of energy. So we just compacted the soil and provide 25 mil layers of crushed rocks at the base. We use the tile walls as gravity retaining walls. You can see in the one of the picture that Martin showed before, the concept of the Earthship, where they use a bit tilt tile walls, but in our design we make vertical walls. I'll show you the drawings a bit later. So to stabilize the walls, we provide concrete ring beam at the top, and that ring beam also help to hold the concrete vaults. We have the spandrel concrete beam at the front. It acts like a retaining wall for his garden on top of the roof, and also we use that to fix to support the roof, and also provide some stability to the walls. We also provide two concrete piers at the front, because the front wall is just white, so we have nothing to hold it, so we provide some piers. We don't have the concrete slab for the main bedroom, but in the wet area, we just provide a concrete slab. The cement vault we use with a backfilling in there for the garden. Because of the dirt is very heavy, so that's why we have more reinforcement than the conventional vaults that if you see in some of the photos of Mike Reynolds' projects. At the front section where we have the greenhouse, we use timber truss roof. So this is I just got some extracts from the drawing. So you can see here we have a compacted soil and gravel for the base. In the wet area here, we have a bit of concrete slab. We have the strip footing here just to support the partition wall there, and we provide the piers here to stabilize the end of this wall and that wall. And we have the ring beams all around, and also at the front here to support, the front tie walls and also the roof. This is a roof truss layout. I think Martin had a bit of problem with, the council or certifier in terms of in South Australia, the registration, they're very strict in terms of roof trusses design. They need like someone to actually, like a truss designer to design, but they didn't accept like the engineering calculations at the first hand, and then we changed.
Yeah, that's right.
Yeah, we changed the design a bit, so we got it through.
The big problem I had with the trusses was I couldn't get them made out of hardwood
By the normal truss,
manufacturer. And council were then like, well, if you're not getting it made by a truss manufacturer, then it gets complicated.
Yeah, it's going, yeah, so yeah. But at the end we get through it, so it's all good. So this is the typical cross section at the back of the Earthship, where we have the berm here. So as Mary mentioned before, we provide damp-proof membrane at the back of the wall, just like in case where we have any water coming in, and we have the egg pipe there to collect the water. Here's the location of the band beam where we tied to the tie walls with reinforcing bars, and also to support the vault. So we do the similar thing with the front section here, where we have the capping beam and the vault. This through the greenhouse, so you can see the steel frame. The timber frame, where we support the top out of this spandrel beam at the front, and of course we provide some trench there for the grey water treatment system. Did we show that in the final drawing, Martin? No, right. Okay. Yeah, because I think we got some problem with SA water, so we didn't show it at the beginning. Yeah. Yeah. So here's like at the wet area and our front entrance. So you can see we provide this pier here just to provide some stabilization to the end of the wall. And this is the detail of the spandrel beam. So we run it like that, so we can retain the soil behind.
Sorry, can you just pick up a little bit? It's very hard to hear in there.
Okay, yep. Sorry. So when we do the structural design, we are aware that this type of construction is not a common type of construction in South Australia and in Australia. So to get the council approval, we have to follow all the steps to satisfy their requirements. So we actually did the soil sampling and soil classification, and I think the soil at the site it's mediumly reactive, and we at that time we made the decision that we would not use the concrete footings. Even there's some problem with the reactivity, but the tie walls are actually quite flexible, and also we use the clay render. So if there may be some cracks in the future, but it can be easily fixed. And we prepare the design report, and our calculation try to prove that the building satisfy all the requirements of the BCA. So we consider all the design loads to AS 1170, and for the concrete footing we still have to follow the AS 9870 for footings, and all the steel, all the concrete reinforced concrete frames and vaults we decide to conform with the Australian standard AS 3600 for concrete structures.
So Thomas, the footings are for internal walls, not tie walls.
Yeah, that's right. Well, just for the internal wall.
Clarify.
Yeah.
Is there any reason you couldn't use ties for those footings?
Sorry.
Is there any particular reason you couldn't use ties for the footings for the internal walls instead of concrete?
Well, I guess it's just I think we just want to make it's quite flat, so we can fix the door frames. I guess you can still use ties as footings, but in this case we have the timber frame partition wall, so yeah, so we made a decision that we use concrete footings.
Yeah, tyres are pretty lumpy and bumpy things to be building a wall on top of, but yeah, I'm sure there's a way.
Yeah, will be your next project.
Yeah.
Yeah, so we prepared the full documentation. So we have all the drawings drawn up, and we have the good structural calculation report to back it up. And Marty submitted everything to this private certifier rather than the council. And once the private certifier is happy with the calculation and the documentation, then he can grant the building rules consent, and you can submit to council for building approval. So as I mentioned before, the tie walls or earthship are not a common term, so we avoid using that term. Instead, we just use ram earth wall. And I guess the reason that the private certifier was happy with our documentation, because it's all backed up by the structural calculations, and in the National Construction Code for Housing, they mentioned that if you have the set of structural calculation to back up your design, then you can get approval. So based on my experience working with Marty and his project, I have some recommendations. If you want to build your own earthship. I guess the base of the tie wall is very important. So you want to keep it dry and all the time. So that's why adequate drainage system around the earthship is very important. Normally, I recommend to put in all damp-proof membranes at the base of the walls, and also on the side of the wall. Because water is in the berm, it can go anywhere. We don't know, so it's better to have a secondary protection. It's a bit boring. That's okay. So if you in the case of the Ironbank project, because we have the curved wall, so we don't have to provide the piers at the back section. But if you intend to build a long wall, then I think at every certain length, you need to provide concrete piers to provide more lateral stability. The ring beam is quite important. For this project, it's to support the vault. But in other, let's say if you use timber roof for your project, then the ring beam provide tie down to the roof, and also help in case of earthquake, because it will make sure all the walls work together.
Thomas, you could use if you were going to do buttressing throughout the house, could you do it like the global model and use tyres as the buttress?
Oh yeah, you can use we call tie piers. Yeah.
So internal walls can buttress.
Yeah, you can use
it.
You can use internal walls. At the moment, we are doing one project in One Tree Hill in South Australia. So it's a rectangular house, but we use internal walls to provide lateral support to the back walls. Yeah, that's right. Yeah. In case of this Ironbank project, we have more reinforcements, steel reinforcement in the vault and also in the ring beam, because Marty wants to put the garden, the soil on top of the roof to have a garden. But if you use, timber framing roof, then you reduce significantly the amount of steel reinforcement, and maybe the size of the bond beam will also get smaller.
Thomas, with the rebar as it going through from the rear beam into the tyre wall,
Yep.
are you using concrete in those top tyres?
No,
Just
we
going to the earth.
just going to the earth.
Okay.
Yeah. So with the flexibility, you can use for the roof construction, I guess you can use the normal roof framing, timber framing, or steel framing if you like. In the project that we are doing at the moment in One Tree Hill, they actually use steel rafters and all the timber battens. Render, on the internal wall faces, it's a rigid render, cement render is not recommended because, we don't have any footings. So because of the soil movement under the footing, under the walls, crack might happen. So if you use the other type of render, soil render, the maintenance cost maybe, the repair is easier and you don't have a lot of maintenance cost for it. Quality of workmanship is very important, especially when when you pour the vault. If you do that, I think that requires a lot of skill and time. And the last recommendation I have is rather to submit everything to the council directly. You better engage a private certifier. So we are engineers. We can work with a private certifier more effectively. And once they grant you with the building rules consent, then you can submit the full documentation to council. So you speed up the approval process from council and don't have a lot of stupid queries, but nonsense queries from them. So I look at Earthship Australia website, and I saw they have a very good document for owners builder. So if you can get access to their website and download that document, is very, very helpful. So I'd like to thank Martin for getting me involved in that exciting project. And I would like to thank you, Rob, and Earthship Australia, to inviting me to come here today. And thank you all for your presence today.
Great, thank you, Thomas.
Yep.
Just got 10-15 minutes for question and answer.
Thomas?
Yes.
Do you estimate the lifespan of this kind of property in your...
Lifespan?
Yeah.
Well, I guess with the concrete structure, normally the design life is about 30 years to 50 years, but it depends on your maintenance regime. If you have let's say good drainage systems, and also it depends on I think the grade of concrete that you use as well. But normally, I guess it's about 30 to maybe 50 years.
And are there sustainable ways to extend that lifespan?
Well,
Would you then go back and upgrade or change or renew the materials to...
I think with the render, depending on what type of work that you require, but the main structure there, I think it can last pretty long.
So is it only the render and the face that you'll have to redo in, say, 30 or 50 years? Or will you have to then sort of pull down everything and start again?
Well, one of Thomas's slides said rendering is not recommended on the tyre walls because they might move a little bit and it might crack, but there's nothing inherently wrong with doing the render if you're happy to deal with some little cracks.
Yeah.
And it's just the kind of thing. It's more of an arse covering exercise, for want of a better phrase. That if Thomas does a design and the client gets all grumpy because there's this little crack
Crack
in
in
their
there.
wall, and some people will complain about that. I mean, I wouldn't give a shit, right? But some people do. And you know, that's their expectation. That's a lot of people's expectation.
Yeah.
So the render is going to get little cracks in it potentially because of the rubbery nature of the tyres and
Yeah.
ground moving a little bit.
Yeah.
But you know, for an external render, who knows? Like, I'm starting to need to do maintenance on my straw bale house render after 10 years. You know, I've got some areas where my lime render coat is starting to crack and I need to repair it after 10 years.
So is the longest lasting kind of render, would that be the concrete render? Would that be like the most durable?
I don't know. I've heard that concrete's not always the best. I think most natural builders will do a lime render. Lime is a pretty durable, time tested. You know, the ancient Romans used a lot of lime.
How's that comparing to like the sustainability? Is it more sustainable than concrete? Have you used that?
I've heard that lime takes less energy to produce than cement.
That's right. Yes. Yeah.
Lime breathes and concrete doesn't as well. Is that correct?
Yeah, that's the way I understand it. Yeah, there's a long list of reasons why lime is better. Like, for example, it can even self-heal small cracks because it sequesters CO2. That's how it sort of sets and goes off by sort of reacting with CO2, and it can actually heal up little hairline cracks.
And you could just use lime in the final coat as well. Like you can start off with like a cob mix and then just use the final coat with lime.
Is it possible to adapt the design for high seismic zones, like for example in New Zealand?
Yes, I think so. I think like what we do is like I mentioned about like the ring beam. The ring beam actually provide like just tie the wall together and then provide lateral support to the walls. Yep.
Yeah.
I was just following on that question about the rendering. I'm wondering about the performance of hempcrete and how long it lasts for.
I think they say it's pretty durable material because it actually over time petrifies and turns into sort of like rock almost. So hempcrete's interesting because there are lots of little air gaps in it, sort of little chunks of hemp which are glued together with the lime binder. But the hemp petrifies over time, so I think they're expecting, and I think it's a fairly ancient method actually. It's not necessarily something new, so I think they've been able to sort of point to historic examples of it, and it's incredibly durable, but I haven't really done my research on the hempcrete. But I tried it. It was actually quite difficult to get hold of because it's not grown in South Australia, where it's illegal to grow, but not over here. But yeah, you still have to render it. You still put a render coat over the hempcrete. The hempcrete is sort of the internal insulative layer.
And is that a substitute for the concrete that you use for the roofing? Is that right?
No, it's not a substitute. Hempcrete in no way is the same as concrete. Don't make that mistake. Hempcrete is sort of a light, non-structural, insulative material. I've heard of some people doing sort of semi-structural things with it, but it's nothing like concrete. The lady in the pink?
You've only got one concrete slab in your area. What's the flooring for the rest?
I'm planning to do an adobe mud floor in the main living area, maybe out into the greenhouse, although I think we might get a bit of water splashed around in the greenhouse if we're top watering with a hose or something, which might be necessary from time to time. So I'm thinking in there slate or flagstone, maybe even a polished concrete floor. One thing I have to deal with is I've got these two big 44 barrel drums, 44 gallon drums of glass where we're cutting the tops off the bottles to make the bottle bricks. So I'd actually like to pour all that into a concrete slab, and I'll do that in the bathroom, but I may even do the greenhouse area, using all that recycled material, maybe some recycled aggregate as well.
Would you consider using, I've seen used before, fiberglass being thrown into like an adobe floor where they've used a mixture of just like the natural clay, the fiberglass, and a bondcrete as well, but I didn't know really like from a sustainability standpoint or just like embodied energy, that application was really smart.
Well, traditionally they use hair, you know, from animals or even people as a binder. What are the more modern ways of doing it, Thomas?
I don't really, but I think like they can use like fiberglass, or they can use like plastic fibers. Yeah, but I'm from Vietnam, and in the past they use a lot of straws as well.
Yeah, like whenever you're making an earthen render, you put straw in as that fibre that makes it strong.
Yeah.
And we were using little fiberglass fibres in our cement mortars for the bottle walls to reinforce the cement mortar. And alpaca. We've got an abundance of alpaca here. And we're also using the alpaca wool to stuff in little gaps in insulation and stuff like that. So, yep.
What about like e-waste? Do you use that as a binder?
E-waste where?
E-waste in like the walls, something like.
Well, you want your tyres to be filled with thermal mass. I don't know e-waste, so you're talking about getting an old television and kind of smashing it into the tyre? Is that what you're thinking? Wires and things in tyres? Well, I'd say what you want in your tyres is thermal mass. And so if you had, wires are thermal mass, or there's a lot of plastic. Maybe if you strip the plastic off and filled it up with metal, metal is also thermal mass. So I guess so.
Yeah, Paul, you have? Sorry.
It's a question about soil types. If you had a project which had, say, a P site, which is problematic and highly reactive, would you use a similar footing system as you've chosen here? Or
I guess it's the movement in the soil. I think the biggest issue is it causes cracking in the walls. So if you have a very highly reactive soil, it depends on the footprint of the house as well. If I think if it's a small what Martin have, then I don't think it's a big issue. But if you have a very long and wide house and narrow and long wall, and I think the movement, soil movement, would be more substantial, and then you have probably more cracks in the walls. But I guess the tile walls are very flexible, so it's not rigid like bricks or something. And you have, when you render it, you put some wires in there as well.
No, we've just got the straw in the render.
Yeah. So I guess the only problem we have that if you have cracks in the wall, and if you are comfortable with a few cracks, and I think that should be okay.
Up there. We're going to make an insurance claim.
Yeah, but if you want to eliminate it, then you have to use concrete footings, and that would be probably expensive, and it's not what we it's not what we want for the sustainability design. Yeah.
Would you be able to insure your house?
Yep. That was one of my questions I put on my survey to all the Earthship people was, do you have insurance on your Earthship? And half of them did and half of them didn't. And half of them had trouble getting insurance and half of them didn't have any trouble. So I guess it's whoever you talk to. But that's an important part of getting approval. You see, if you don't have approval for your Earthship, you're not going to be able to get insurance and you might not be able to sell it either. Yeah, up the back.
Did you get a bell rating for the finished build?
Yeah, actually that reminds me of a few things I should have talked about in my presentation. The bell rating is only 19, so it's not super hazardous because we've got a large cleared area around the home. But the guy from the CFS who came out to do the assessment was really pleased with all the earth sheltering, the earth berm around the back, the green roof, gravel roof on top, because that's all very non-flammable, and the only part of the building that is susceptible to fire is really the greenhouse structure out the front, which can be protected with sprinklers, for example. And the other thing I should have mentioned was energy assessment. That's part of, sort of the second stage of getting development approval. The energy assessment, I got a 6.3 star rating, which is only 0.3 higher than the minimum. So that was disappointing, and it just indicates how how poorly the software that the energy assessors have to use, how poorly that deals with something like an Earthship with a greenhouse and an earth berm and all these unusual things that the software's never had to deal with before. So hopefully with my temperature sensors in my Earthship, I'll be able to demonstrate that it's a 9 or 10 star home and that the 6.3 stars was a load of crap.
Just have one more question.
One more.
Did you, like in conventional construction, when you put your timber frame up or whatever it is, that at that point you get the building surveyor comes in and says, yes, it's fine, you can go on to the next stage. Did you have, how did you get like your tire wall? Did you yourself have to certify that in place of the building surveyor or anything like that? Is there anything like non-conventional about that? Like that standard procedure?
No, we only did the inspection for the roof and for the steel reinforcements. I guess with the tile walls, we. I think we just.
Didn't you come up to my place and you went, yeah, that's a good wall?
And where do we get engineers like that? Do you all hang out somewhere?
I mean, because the wall is just designed, in this case, it's designed, just gravity retaining wall, and the top actually tied, with, the bolts. So, the main, concern to us, is he has to do, the concrete structure right. We don't have any issue with the wall. Yeah.
I mean, I was kind of half joking, but the serious bit is I think it actually worked in my favour that I started out building this wall with no approval, and then, but sort of knowing full well what I was doing. I mean, I'd been to Taos, I knew how to build a tire wall. But had I followed the usual route and, sort of gone to an engineer and said, I want to build this tire wall and I think it would have been more likely that I would have ended up with steel reinforced concrete footings underneath. But because this tire wall was already there, and I invited Thomas out to come and have a look at this thing and give it a good slap, and guess what? It doesn't move.
Yeah, and also the footprint of the tire is 650 wide, yeah. So it's in terms of bearing, I don't think there'll be any issue.
I mean, I guess what I'm saying is when you can see this thing standing in front of you, and you can kind of kick it and sniff it and whatever, you sort of get a sense of how it's gonna work. I mean, I had trouble finding. Well, when I say I had trouble, the first engineer I spoke to was just like, nah, I'm not doing this. You've got to have concrete footings down there. So I was, starting to panic, have a look through the phone book, whatever, found Thomas, and he was open-minded about it. Yeah, let's come and have a look at it. Let's think about what's going on structurally, and I mean, the other frustrating thing is, look, this is nothing new. Mike Reynolds has been doing this for decades now. And sure, there are different things here. We've got things like termites, which I didn't mention. And so, I've used all materials that aren't prone to termites. I've used hardwood timber for the framing, and because I don't think you can keep termites out of a tire wall. But, we've also got different soil types. And, this is what the engineers in Australia were telling me. It's like, well, it might be all very well for Mike to do that over in Taos, but he's got different type of soil. We've got highly reactive clay soils. And therefore, there might be more movement in the wall. Yeah,
but what I just when Martin talked with me about the footings, I just in terms of bearing the soil, what we have, it's pretty good. The only issue that I mentioned again is reactivity of the soil only cause cracking in the walls. So if you are happy, if the owners is expect some cracking happen and happy with it, then there'll be no issues. Yeah, we just don't want people to come to us and say that we have few cracks in our house and it's not safe, and sue us, and that we don't want. We just want to make sure that the wall is safe but cracking we can't eliminate 100% of cracking in the walls.
And it's all about can I just say one more thing?
Sure, of course.
It's this whole issue with getting approval and stuff like this. It's all a legal thing. It's because we like suing each other when things go wrong because we don't accept the responsibility ourselves. So it's the same with the grey water system. And ultimately, what I'm doing with the grey water system is I'm saying I'm taking responsibility because I feel confident no one's going to die. So I'm happy to take on that risk. I mean, what's the worst thing that can happen? You know, maybe someone gets sick from eating a tomato that they've picked out of the grey water system. You know, that's probably the worst that can happen. I think the chance of that is zero. And it's the same with the tyre wall. And so, you know, the first engineer I spoke to said, look, my professional indemnity insurance just can't cover this if something goes wrong. I would have to pay more for my professional indemnity insurance, you know, to protect him if I sue him kind of thing. So it's all this game of who sues who, and that's the same with the council. I didn't tell the story about how a council came and told me to stop building my tyre wall when I put in my plans for planning approval. All of a sudden they got interested in what was going on because they knew what was going on because I put in my plans. So they came out and said, hey, you're not meant to build until you've got your full approval. And that's because, again, legal issues. If someone gets hurt on that site, if I fall off the wall pounding tyres and council knows about it, then council's in trouble. You know, they'll get sued because they haven't exercised their duty of care or whatever it's called to, you know, towards idiots like me who go ahead and do things without approval.
So would you suggest that as a way to start is just bang the wall up and see how she goes?
Well, seriously speaking, you're allowed to do a retaining wall up to about a metre high without any approval. So as long as you've got the you know, as long as you haven't done anything daft, like as long as you've got your damp proof course under there, as long as you're anticipating turning this into a full-on structure, a house, and you know, you can do that, yes.
Yeah. There's one good question, like, at the back asking about, like, whether we can build two-story house with a tile. I think, like, theoretically, like, I think we can, but it depends on how you want to put, like, the berms at the back of the wall. In that case, we may need, like, to have, like, probably bond beams, at the first floor level, and we probably have to introduce some piers or some lateral some structure, like, to prevent the wall from falling over. So, but I think it can be done. It can be designed.
That comes down to design issues as well.
That's right.
The two-story one I've seen in Taos is actually a round tyre tower, and round structures are really good. And
That's right. Yeah.
That's going to resist any tipping forces.
Exactly. That's right. Yeah.
Could I just ask one more question about the drawings and the research that you had to do for Marty's project in terms of the structural research?
Well, I guess I of course I got some nice pictures like Martin gave me about the project in the US, and I attended the seminar by Mike Reynolds, so I knew that structure already been built somewhere in the world. The only thing we have to do is just to do the calculation to verify that with the weight of the wall and with the bond beam, the structure can resist the lateral force from the earth pressure or from the earthquake. And once we approve that, the wall have enough, have sufficient capacities, then we said that is fine.
My question was, how can other people use those calculations and that information that you've already come up with to then go to find an engineer in Victoria, let's say?
They have, so I guess they have to probably talk with the engineers, and I can't provide that calculation to the other engineers. They have to do their own calculations. But they may. I asked a similar question that I asked Marty before. That do you accept? There's some cracks in the wall. If you said that, that's fine. I have no issue with that. Then, that should be okay.
Does that mean Earthship designs are not transportable and highly site dependent?
Sorry, can you say?
Does it mean that the designs are highly site dependent and therefore not that transportable? The plans and
No, I don't think it means that.
No.
You could, in many ways, the design for my Earthship, which is on some quite reactive clay soil, pretty much a worst case situation. So the type of, you know, the amount of steel we have in the ring beam and things like that, that's also related to my roof design. But no, it's transportable to different sites. But I think the point Thomas is making is that you really do need an engineer.
Yeah.
And I'm sure this is the same for Mike, is that, you know, you still need an engineer to sign off on the peculiarities of each design, depending on soil type. But yeah, I mean, to a certain degree, I mean, one of my ambitions is to really follow in Mike's footsteps and come up with some standard designs that people can just buy off the shelf, and all the engineering is done for the worst possible soil type kind of thing. Or maybe Thomas comes in and goes, oh no, we can decrease the amount of concrete here because you've just got some nice soil kind of thing.
How long do you think that's going to take before that's
Yeah, well, I've just sort of taken my first step. I've registered the name Earthship Eco Homes. That's my trading name now. I'm serious. Thank you. And my next big step is to ditch my day job at UniSA. So I'm hoping to. I mean, it's nice to have one foot in and one foot out, but I think eventually I'll just have to step out of it. And yeah, but I'm excited about that. And yeah, I've got this big job in Queensland, so I'm stoked about that.
Awesome.
Is the job in Queensland Council approved? Or?
It will be.
Awesome.
Will that be
Thomas
before or
Thomas
after?
is status in Victoria?
Yeah, Thomas is.
Yeah, our company registered in Victoria and also in Queensland. Yeah, so.
Yeah, you can do work all around.
Yeah, we can do work all around
And
Australia.
what are the logistics of hiring yourself to do a build in Victoria in terms of you making site inspections, this kind of stuff?
Well,
how tricky is it that you're interstate?
I guess for we do a lot of work like in the bush, in South Australia. So we might do the first inspection, and then for the subsequent inspection, you just send us the photos. If we are happy with it, and then you get to send the photos, and we say that we're happy with. Yeah.
Great. Thank you very much.
Okay. Thank you, everyone.